Hey everyone, my name is Sanvi and I'm a junior at Stevenson High School. I hope you guys are all doing well and staying safe during this time, and this presentation is the 8th part of an online community initiative designed to introduce STEM and medicine to students who might not have had the opportunity to explore these careers, and today we're going to talk a little bit about data science and applied math. So data science is a field that uses scientific methods, processes, algorithms, and systems to extract knowledge and meaning from data, and this can involve both structured and unstructured data. The field of data science can have many different applications across many different industries, and a few examples are like finding and developing new drugs and medications, and even things like predicting stock market trends. Kind of along similar lines, applied math is the application of mathematical methods and models to different fields, and some of the most prominent examples are biology, chemistry, physics, engineering, business, and computer science. The possibilities are really endless with the applications, and it can involve things like making complex models of atoms and molecules, and even figuring out like when would be the best time to invest, how much to invest, which companies to invest in, things like that. So there are many different careers in data science and applied math, and the first one that we have listed is business intelligence, which involves taking raw market data and analyzing it to make the best possible business decisions and strategizing in a way that will optimize profits. Next, we have machine learning engineer. So machine learning is basically when a machine is given a large amount of data and quote unquote learns to perform a certain task according to the data it's given. And machine learning engineers would build machine learning infrastructure and research new methods or approaches to machine learning as a whole. The next career we have is bioinformatics, which involves collecting and analyzing large amounts of biological data. Lots of biological data can be very complex and intensive. For example, like genetic codes, there's so much data that can be difficult to analyze manually and can be very time consuming. So bioinformatics really serves to streamline that whole process and can allow us to do things much more quickly and efficiently. Next, we have statistician. There are many different applications for this career, and they can work in nearly any field. But at the most basic level, statisticians use statistics to extract meaning from raw data and then use that meaning to inform decisions and give people advice on what exactly is the best for them or for their business or for their data. So getting into some of the latest advances in data science and applied math, the first one we have is data analysis automation, which is the process of developing computer programs and systems to analyze data. So these would require little to no human intervention. So the main purpose of this is to greatly increase the efficiency of analytical tasks, which can make us make further advances in other fields much more quickly. The next advance we have is the Internet of Things, which is connecting different devices through the internet. And this is already becoming so prevalent in our lives. And essentially what it does is this can allow different devices to send and receive data to each other through the internet. And this can also just greatly increase the efficiency and quality of our own lives. But there is a little bit of a debate on this being like whether our lives will become overly surrounded and overly dependent on technology versus having like a healthy balance between technology and the lives we live. So there definitely is a bit of like a fine line to walk there. The last thing we have is explainable AI, which is humans essentially being able to understand why or how artificial intelligence makes the decisions it does. And currently, with artificial intelligence, we don't really know or see how it makes decisions, and this can lead us to trust it less. So if we can explain and justify the decisions it makes, it can increase the trust in these systems and can also increase transparency. And both of those two things combined makes it really likely that it could be implemented on a much larger scale in the future. So that's all we have for today. Thank you guys so much for listening. It has truly been a pleasure to do this whole series, and yeah, I hope you guys gained something from it.